Okay, find the equation of the edge between the sites. Here it gives it to us, E and K in the form y equals mx plus b. So we just talked about that. We need to find the midpoint and we need to find the perpendicular slope. I'm going to do the midpoint first. So the midpoint, remember, is the average between your x and y values. So 10 and 23. And then your original slope is going to be negative 10 over 4, which is negative 5 halves, which means that your perpendicular slope is going to be positive 2/5. Okay, we take those values and we plug them into your point slope form. Y minus y1 equals m times x minus x1. It says we want it in y equals mx plus b form, which means that we need to distribute the 2/5 as well as get the y by itself. So we get that y is equal to 2/5 x minus, and then 2/5 times 10 is 4, so minus 4, and then we're adding 23 to both sides. So we get that y is equal to 2/5 x plus 19. And there you go. All right, example 2, which is our last example for today. Create a Voronoi diagram for these points. So we have 4 different points. We're going to try and focus on each triangle at a time. So I'm going to focus on the ABC triangle first. So realize that we've got some nice things going on with triangle ABC because it's a right triangle. So your slopes and your midpoints are going to be pretty easy to find. So I'm actually just going to go ahead and draw those in right now for AC and BC. So the equation of the perpendicular bisector between the points A and C is going to be vertical, which means it's going to be x equals a number. It's going to go through the midpoint, which is 4. So it's going to be x equals 4. So drawing that in is right here. Between B and C, it's going to be a horizontal line. So it's going to be y equals a number, and halfway between 0 and 6 is 3. So we've got this guy right here. Now, remember that the point of intersection for all 3 of these points is going to intersect at the same place. So since you already found the point of intersection between those 2 points, it's going to be the same point of intersection for the perpendicular bisector that goes through AB. So just sketching out the perpendicular bisector of AB, it's going to be something that looks like that, and it's going to go through that same point. But since I don't know what those are yet, I'm going to quickly calculate the perpendicular bisector for AB. I might label it as AB as well, just to keep track of which perpendicular bisector I'm discussing. So I'll do something like AB. Let me get it on my other computer screen real quick, so I don't have to worry about zooming in and out. Okay, so midpoint for AB is going to be 4, 3. And the original slope for AB is subtracting the y's, so 6 over subtracting the x's, which is 4, so that's 3 halves, which means that our perpendicular bisector is going to be negative 2/3. And then since we don't need to write down the equation, we're just constructing it, we can go to that point, 4, 3, which, hey, is the point of intersection. And then we just draw in the slope, negative 2/3. So we go down 2 over 3 or we could go up 2, back 3, right? Going back to, it's all kind of coming together here of what we've learned this year. So now we've got these 3 lines that are intersecting, but there's so many that are going in places where they shouldn't be going. So I want you to go back with an eraser and follow the perpendicular bisectors. So the perpendicular bisectors between A and C follows up here, 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 here. And then once it hits this point, we don't need to have any of the extra ones going into their space or their cell, right? And then hold on, stay with me. So then following the perpendicular bisector between B and C, we know that that is the cell that we're creating. So I'm gonna go back in with my eraser and erase the extra line that's going through there. Same with following the perpendicular bisector between A and B. Go until you hit that point, and then go to the cell that contains A and erase that extra line. Same with the cell that contains B. Go in there and erase that extra line. And now we've created that part of our Voronoi diagram. So what's nice then when we move on to the triangle BCD is that we've already got the perpendicular bisector for BC. So now we just need to find the perpendicular bisector for CD and BD, and then find where they all intersect and then draw out from there. So finding the perpendicular bisector for BD, I'll do it in red, so we need to find the midpoint, which is just the average of your 2. So adding, this one's not nice and even, which is a bummer, but adding 6 and 15 is 21, dividing by 2 is 10.5. And then 6 and 3 is 9, divided by 2 is 4.5. And then the slope is 3 minus 6, so negative 3, over 15 minus 6, which is 9. So negative 1/3, which means that our perpendicular slope is going to be positive 3. So then we go find the point, 10.5, 4.5, 10.5, 4.5 is going to be like right there. And then going up 3 over 1 or down 3, 1, 2, 3, back 1. So that would be a line, or sorry, a point that's contained on that same line. Or we could go up from the original 10.5, 4.5, go up 3, 1. You can't see what I'm doing with my hands, but I'm jumping up 1, 2, 3, and then over 1. So I found 3 points that are on that perpendicular bisector. So if I were to draw in that line, that would be my perpendicular bisector. So I'm already finding out about where that intersection should be. You could already start thinking about like which parts of the line you would erase, right? So that line that went below that horizontal line is probably going to be, it will be erased. But now I'm going to do CD real quickly. Okay, so the midpoint for CD will again be, because it's 6 and 15, so add those two together is 21, and then divide by 2 is 10.5. And then 0 plus 3 is 3, divided by 2 is 1.5. So that's your midpoint. Our original slope between C and D is 3 minus 0, so 3, over 15 minus 6, which is 9, so 1/3. So then the perpendicular slope for this guy is going to be negative 3. So finding the midpoint, 10.5, 1.5 would be this guy right here. With a slope of negative 3 means I can go I can't go down 3 because then I would be off the graph. You can kind of guess it. So you can go down 3, right 1. So down, I'm just jumping with my finger, counting it. 1, 2, 3, back 1 would be something like 1, 2, 3, something like here-ish. And then going up from the original midpoint, going up 1, 2, 3, back 1 would be right there. So connecting those 3 points and realizing that this perpendicular bisector should be going through the same circumcenter as what the intersection that we just found. So kind of trying to eyeball that guy. Something like that. So then this is our perpendicular bisector that hits at the vertex. And this is our perpendicular, oh wait, nope, lied. This is our perpendicular bisector of BC, which hits at that point. And then the perpendicular bisector of BD. So then going back through and erasing the extra lines, you now have a Voronoi diagram that is complete. Ta-da! Okay, so it's all about perpendicular bisectors and being able to create perpendicular bisectors and drawing them all out. You will be drawing them on your homework. So if you can print, printing is a good idea. If you cannot print, graph paper. You should definitely, absolutely be doing this on graph paper. Or if you can do this on a tablet, that's also good. Okay, let me know if you have any questions.